Thank you very much. Thank you for the opportunity to showcase our solutions here. We're at OPT. We do a lot of projects in different kind of regions, and in this way we would like to introduce a bit more about our solution, what we did with our global partners and our staff in tab bending with machine vision. So short about, give you some introduction about OPT. We're a Chinese-based company and leading for vision components and a big software supplier for factory automation globally. For that, we see us as a world-class manufacturer, what can be adjusted to every kind of machine vision application. This is the big brain behind. With our global network, we're doing any kind of applications with more than 2,800 employees. And like you can see, you find us everywhere in the world. So that's why we established our branches as well here in Germany with 2 subsidiaries in Stuttgart and in Berlin, but also in every kind of the world where you need our solutions. When we talk about tab bending and about machine vision, we always have to capture an image. For that, we use nowadays our own camera portfolio. This starts with 0.3 megapixel and can go up to 150 or more megapixel in the future. In this case, we don't go up to 150. We will stay in the normal ranges. We do this always from scratch for our projects to establish a hardware what is ready to use for everyone in the branch. So having an image needs also having a small lens, and this is also one thing what is always matching to our hardware is the second supply of the lens. So, but enough about OPT, now let's talk about tab building. First, what do we do? What is the thing? We have 2 methods for battery tab forming process. One process is segment cutting and winter welding. It's also mainly part of the stacking machines. So you have the positive and the negative plates, and they are cut into 2 pieces and matched together. Or you have the second plate, the continuous winding, where you also wound positive and negative parts together and execute this with a laser cutting process. Beside these processes, you have always the thing about finding the perfect cutting process for the laser, for example. Like you can see on the upper side, an OK sample should be looked like that the overlayer is folded over and the rest is there. But for any kind of processes, we don't have only the good forms. We also have the energy where we have the benchen a bit too small, the tab is damaged, also the tab is ringed. This is also not working for the continuous projects. These are the basics, but there are some specifics where it's quite difficult, especially the variance and the misalignment in the machine is very complicated in this record. The tabs are very difficult because they have different shapes. You have to think we have 2 different materials with the anode and the cathode, and has to become together, which makes always a natural reflection. Then we have the reflection challenges. What I mentioned here is the significant reflection over the time, and also the difficulties that the inner labs are difficult to cut directly. What did we do here? We did this with one of our clients in China together over the long time. And we brought there, together with our internal staff, a technical solution what is based out of a hardware, software, and also the integration part, what we did here. And this is a combination of light sources and image solutions. I will go on the next slide a bit more in detail because then it's more clear. We separate images from aluminum and copper. We don't want to mix match this together for better image quality and also to define in which kind of directions we want to go. Due to the fact that in any kind of the tab welding processes, there's not much space for any kind of machine vision products, we had to use here a lot of prism to proceed any kind of light sources. And for the last but not least, we introduced in this project our first deep learning project, where we're working direct with partners, but this is also our one. So, but what did we do? You have to see the tab is laying in the middle. On the left side, you have the anode, and on the right side, you have the cathode. And every side is inspected with 3 cameras. I will go in detail about which cameras we are using here, but you have a light source for every camera, from the upper, from the lower, and from the left side. So in the end, every tab will be inspected by 6 cameras, and every step. The hardware is just normal monochrome matrix cameras. From the upper side, and from the other side, we have colored cameras. For the forward front side, we have 20 megapixel cameras with a field of view of 60 to 40 millimeters, so it's not so big, to get a pixel resolution from 0.01 millimeters per pixel from the side. And from the end, we get also, with a 20 megapixel sensor, a 100 to 73 millimeters image for a pixel resolution of 0.02 millimeters per. All in all, this is only the camera hardware. In this project, we preceded 6 cameras, of course, 6 lenses, but also very unique lights. For this application, we designed a new light solution based on a half-shaped ring light, what illuminates exactly that what should be seen. So the tab from the over on the lower side, and like we saw in this case, there's not enough space. So like we thought, we're using prism, we're using any kind of solutions that is possible to see the tabs in this case because there's no space. And how does it look like in real? From the upper and then the lower side, like I said, from one side we're using matrix cameras in monochrome, and from the other side we're using the color camera. We have the tabs, what needs to be inspected. So this is just the ground truth for fulfilling up the pipeline for deep learning. To conclude this, we have the left side, the right side, and the end phases, which are now separated for our pipeline, what comes next. The tabs are now laying side by side. We can detect the foldings, and we can also detect the surface. But now we had the issue, how could we proceed? Because normal standard algorithmic is quite hard to implement for these, where you have very different sources of raw material, what always look a bit different. Okay, from the images like we saw here, we're reducing the reflection, but you can't never reduce reflection to 0%. So what did we do here? We worked here with our own Deep Vision 3 platform. This is an AI vision platform, what is a self-development core platform. We have some features there inside. Okay, we're using a supervised algorithm, this is clear, but we have an automatically assigned computing power to reschedule the task, especially when you get a new charge for tabs. Because every charge of tabs we found out are a bit different, and there's always a need for adjusting the AI model behind. Due to the soft nature of the tabs and the very high number of the tabs who are laying side by side, we have a very high variance. We have also the reflection, and this brought us to the point that we needed a very big comprehensive model in this case. We had also the issue, we had not so many good or for example, bad parts to implement. So far we had to train algorithmic on synthetic data where we produced on our own. Our OPT solution was that we, like I said, we produced the data with a generated advertising network to target the deep learning aspect behind. Then we started with the ground data. We have the anomaly detection in the base with 3 classes. We had the winding, what would be good. We have the reflections, what would be okay, and we have the NG. So, for example, a winding is allocated now on the right-hand side on the lower point, where you see, okay, there is it. And due to the fact of the model that it is trained, it is workable. But then we have also something different applications. So, for example, this is also the side effect of the depth, where you see in the red box, for example, an NG of, okay, here's something different. And we have to see that there's not only these accurate image, there are any kind of variance here in this defect. We can see also on the lower side it's defect, but on the upper side, okay, this should be clear. But this is one example. Then we made the first dry run in our office, and where we tested 50 OK and 50 NG before we made the deployment. For the first results, it was great. We convinced the client to proceed with us. Then we made the first deployment in the machine, where it was looking like that we saw the same what we had some minutes before. We had the upper and the lower side on the management board. But then we had some difficulties, and this is something what faced us a long time till we could finish it because of the software parameter. And this is the Messe analytics, what we always see, and where we see our strength with our own employees who can transform this for the future. Because on the left side you have this Messe analysis, in the middle, then also the second one in the middle, and also the correct detection, what was misclassified. And this brought us to this point that due to the fact the customer also said, okay, now we want to improve ourselves a bit more, and went into the next direction. So far, we had to find now these errors. Then we had a retraining, and now what was working. These images were quite easy to find because the tabs are in this shape that it was easily to calculate. But this brought us to one point, what we learned in this application, that the anode was quite different to annotate than the cathode, because of the material, and also because of the reflection, and because also of the cutting process before. The cathode is softer than the anode, and this brings to more frequent tab stacking, and also to a recognition anomalies what we have behind. That's why we had to train 2 different models in the end for each side. And also, the different foil material causes to inconsistent and in the detection of the defects. But in all, we started the deployment. We retrained our model over the time, and then after the total results of 80,000 images, we could find new missed defects after retraining and retraining the model. But the only thing what was to mention, and also what the customer wants to improve in the future, is the overkill images, what we saw some minutes before, because here with an overkill rate of 0.8. This is something where we believe we can improve for the future. But that's it, how we fulfill a project. Thank you.